Today we're going to learn how to solve trig equations using some form of factorization. And in the first example, we've got to determine the general solution of 2 sine alpha tan alpha minus tan alpha is equal to 0. And we need to factorize this equation first. Now I notice there's a tan alpha and a tan alpha, which means I've got tan alpha as a common factor. And I'm left with 2 sine alpha minus 1. Now, very, very important, you may not divide by tan alpha. It is going to provide you with one set of solutions. So in this equation, either tan alpha will equal 0 or 2 sine alpha minus 1 will equal to 0. So I've taken my quite complex trig equation and I've split it up into two simple equations. Now, first of all, tan alpha is equal to 0. So if I type that into my calculator, shift tan 0, I will get a reference angle of 0 degrees. Now we need to move into quadrants. Now 0 is neither positive nor negative. But strangely enough, you'll get exactly the same answer if you decide to treat it as a positive number or a negative number. So for me, it's easier to decide that 0 in this case should be positive, which means that tan is positive in quadrants 1 and quadrants 3. Now remember, tan has a shortcut. You can choose to work in only one quadrant if you add k times 180. So in quadrant 1, we just work with angle theta, or angle alpha in this case. So alpha is equal to 0 degrees plus k times 180. And remember to state that k is an element of integers. Moving over to the right-hand side and our other set of solutions. If 2 sine alpha minus 1 is 0, I can take 1 across to the other side, so 2 sine alpha is 1, and I can divide by 2, so sine alpha is a half. We need to decide where sine is positive. So sine is positive in quadrant 1 and quadrant 2, so I will work in quadrant 1 and 2. Now first of all, my reference angle, shift sine a half, will give me a reference angle of 30 degrees. Now the rule in quadrant 1 is just the angle. So in quadrant 1, alpha is 30 degrees plus k times 360. And in quadrant 2, the rule is 180 minus the angle. So alpha will be 180 minus 30 degrees plus k times 360. And 180 minus 30 degrees is 150 degrees plus k times 360. And we have already stated once per sum that k is an element of integers, so I don't need to say it again. Let's look at example 2. Determine the values of x if 3 cos squared x minus 10 cos x plus 3 is equal to 0. Now they haven't given me an interval to work with, so I can assume they're asking me for the general solution. Now with this one, I don't see a common factor. What I do notice is I've got cos squared x, then cos x, and then a constant number. Does that maybe look like something you've dealt with before? What about a trinomial? Maybe it's easier to see it if you use the k method. So instead of cos x, I'm going to write a k. And then you end up with 3k squared minus 10k plus 3 is equal to 0. So all I've done is substitute cos x with k, and it does make it easier to see. So if you get an equation and you don't know where to start, try and substitute the trig function with one letter and maybe it will become clearer to you. We can factorize this trinomial. It will be 3k minus 1 and k minus 3 is equal to 0. That's much easier to work with, but now I need to put my cos back in because I need to solve for x. So I end up with 3 cos x minus 1 times cos x minus 3 is equal to 0. Now we are using the k method that we were taught in algebra, but those yellow steps you don't necessarily need to show. You can if you want to, but if you can factorize without doing it, you're also welcome to. I'm going to carry on and get two different sets of solutions. So either 3 cos x minus 1 will equal 0, or cos x minus 3 will equal 0. Let's look at the first equation. I can take 1 over to the other side and divide by 3, so I get cos x is equal to a third. Now we need to decide if cos is positive or negative. Now in this case it's positive. Well, where is cos positive? In quadrant 1 and quadrant 4. So we'll work in quadrant 1 and quadrant 4. So I need to find a reference angle. So shift cos a third gives me a reference angle of 70,528, and we're not rounding off just yet. In quadrant 1, x is just equal to the angle, so 70,5 degrees plus k times 360. And the rule in quadrant 4 is 360 minus the angle. So x will be 360 minus 70,5 plus k times 360. And simplify, you get 289,5 plus k times 360. And remember, k is an element of integers. Moving over to the right-hand side, we still have that equation to solve, and don't forget to do it. We can take 3 over to the other side. And if you type this into your calculator, you will get a maths error. Now let's just remind ourselves, why do we get that? It's because the cos graph cannot go higher than 1 or lower than -1. So there's no real solution on the right-hand side. Let's look at example 3. I've decided to do another trinomial because it is a difficult question to answer. So 2 sine squared x minus 5 sine x minus 3 is equal to 0. And hopefully you recognize the format of a trinomial. But if not, if you're stuck, substitute the trig function with just a single letter. And then we notice that 2k squared minus 5k minus 3 is equal to 0. And maybe then you will see the trinomial. If we factorize, we get 2k plus 1 and k minus 3. And we can now put our sine x back in now that we've factorized it. So I end up with 2 sine x plus 1 and sine x minus 3 is equal to 0. And just a reminder, you don't need to use the k method, but do it if it makes it easier for you. Alright, going on to our 2 separate sets of solutions. The first one is that 2 sine x plus 1 is equal to 0. And the other one will be when sine x minus 3 is equal to 0. Let's look at the left-hand side. So 2 sine x plus 1, I can take 1 over to the other side, becomes negative, and divide by 2. So I should be looking on the cast diagram where my sine is negative. And sine is negative in quadrant 3 and quadrant 4. So we need to work in quadrant 3 and quadrant 4. Now we've used our negative, we're not going to use it again. To find our reference angle, we just go shift sine a half, and we get a reference angle of 30 degrees. The rule in quadrant 3 is 180 plus the angle, so 180 degrees plus 30 plus k times 360, which we can simplify to 210 plus k times 360. And the rule in quadrant 4 is 360 minus the angle. So x will be 360 degrees minus 30 degrees plus k times 360. So I end up with 330 degrees plus k times 360. And remember, once per sum, you need to tell us that k is an element of all integers. Moving over to the right-hand side, and don't forget to solve that equation as well. If we take 3 over to the other side, we get sine x is equal to 3. And like the previous example, your calculator will give you a maths error because the sine x graph does not go higher than 1, so there's no real solution on the right-hand side. There are a few on the worksheet that you can now attempt. Thanks for watching Max Maths. If you liked what you saw, please like, share and subscribe.